in the brief, which I presume all of you have got. And Jimmy introduced the project last time where he talked about the idea of an auditorium, and he essentially crystallized what an auditorium is about. He talked about the idea of an insular volume, which is used as the space which can be used for various activities. And of course, you'll have to determine the nature of activities for the site you are selecting. And for that space, obviously, there are three things which you have to understand and which we have written in the brief. Firstly, because it's a space which has to be column free, you are already thinking about a large span. Okay. Now, when we say large span, uh, anything above 6 to 7 meters is kind of looked at as a large span, because we say the general kind of thing is 7 meters, maximum push to 8 meters, that kind of a thing. So that's one of the things. So one of the first challenges of the project is, can the structure be planned to take a large span, be lightweight, durable, flexible, and sustainable? Okay. Um, so that's one of the things. So we're not talking about a temporary kind of a building, okay, which comes up like a pavilion in the Kochi Biennale, where they build these auditorium spaces out of bamboo and then it disappears. So that's the first challenge. The second challenge is, could there be a way in which other options are possible for sustainable use of auditoriums in terms of correct thermal visual comfort without resorting to high-end technologies? Okay, so you have to understand that when you talk about a large space like this, there are various kind of requirements. Okay, there are various kind of requirements. Of course, you have seen in these COVID times how how a hotel converts into an isolation ward for COVID patients, and how various things happen. You have to also understand how these auditoriums, you have to decide based on the context whether what are the nature of activities which can happen within that space. I think that's something which you need to kind of figure out. Okay. And when we say high-end technologies, I mean, can you also talk about giving out this auditorium space for an activity which does not require air conditioning? Then how do you cross ventilate it, etc., etc.? Of course, there are its own problems, but if you're looking at a small place, in a rural place, and you don't have electricity, okay, you have electricity in phases, or it comes on a particular day it's not available because of load shedding, then do you mean to say that the auditorium cannot be used? So I think the technological challenge here is to actually think about that. Okay. I mean, you all know the various contexts that you are dealing with, so automatically that's the second issue. And the third issue is, how do you kind of, as architects, okay, we're always concerned about the land, uh, and how you are kind of. Meenal, have you started recording?
No, somebody else has started recording.
Okay. So when you talk about the land, and you have auditorium as an insular volume, as Jimmy said, and then there are kind of allied spaces like the foyer area, the washrooms, the green rooms, the storage area for chairs, maybe a little cafeteria, etc., etc. And if it's a cafeteria which cooks some meals, then automatically there'll be a little kitchen. So we have given you a flexible kind of area statement, and we are saying, how do you kind of make a footprint which is really tight, you know, so you need not start sprawling it around the place, etc., etc. So you're talking about a kind of a building which is really tight, well worked out. I'm not saying that obviously all these functions, we are simply talking about an auditorium, so now we're not talking about too much about the like a conference room attached to the auditorium or something like that. So how can you work this out? So these are the three challenges which you have to keep in mind throughout your project. and the materials you work out, the technology you choose, etc., is based on all these concerns. These three concerns which were put to you. One actually talks about structure and construction. The other talks about services, okay, and sustainability, and of course the last talks about architectural design. So what comes first is not the issue. The challenges of the project is something which we have put out to you. Okay. So with that in mind, I'm actually going to show you one of my projects. Okay. Which wherein we kind of had, there are different issues, and I will demonstrate through this project how we went about doing this. Okay. There are concerns as architects that are very important, which you need to kind of engage with, but also you need to understand that there are your own personal concerns, and of course there's a client, there's a structural engineer, there's a HVAC consultant, blah 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 blah, and the architect. Okay, very often the architect is the conductor of this orchestra. Okay, you have one of your friends here who actually plays in an orchestra, Fleur by name, and the architect knows or is supposed to know all these aspects. And very often we absolve ourselves of these responsibilities because we claim we are not interested in it. Okay, but if you do not know all of this, you will not be able to raise questions and ask critical questions vis-a-vis structure, vis-a-vis services, vis-a-vis various kind of things which you are in charge of. Okay, you're getting paid to do all of this and you are in charge of it. So right down to the bill of quantities to the tender document is our responsibility. And for projects of this scale which we have given to you, and maybe even 4 times the scale or 5 times the scale, we are competent enough to kind of manage this without a whole set of specialists to kind of come in. Anyway, so going with that, I'm going to talk about design, design development, and details, which adds, which kind of leads to great architecture. Okay, uh, as I said earlier, it's not that one comes before the other and the other comes whatever, etc. It's all simultaneously, and you'll have to learn to think simultaneously to make these decisions, etc., etc. It's not like okay, ye pehla aega, wo pehla aega. Maybe in some cases your concerns, because you are more services oriented, your concerns may stem for that, but it doesn't mean that the functioning of the building or the layout of the building has gone bonkers. Okay, it is all integrated, and you need to understand that all these three aspects happen one after the other. One I wouldn't say after the other, I would say would happen simultaneously, but your concern may be more about getting the functions right first and then move into materials. But while you're doing the functions, you're also thinking of the materials. Yeah. So I'm actually going to talk to you about this project which I've done. It's basically a church in Malad East. I will tell you a lot of stories and various positions which were taken, etc., etc. So the client comes to me sometime in, I don't even think whether it's 2012, because the imagery says 2012. Yes, maybe it's somewhere around that time. Where the client comes to me and says, Ainsley, I want you to design this building of mine, and it's in Malad East. Okay, and when he comes to me, he actually just says, that's all. Okay, and he says, okay, we definitely need, so he calls it a church. Okay, and he tells me that the site is approximately this whatever. But if you look at the marking of the site, which is in Malad East, this is Pathanwadi, um, and you see that it's like a rectangular plot. Okay, he has not given me the dimensions of the plot, but we start working. Okay, and from that rectangular plot, we assume from a Google image, we out some kind of an idea of what the site plan would be. So we kind of create these boundaries. He gave some approximate dimensions, which we actually took, and we said, okay, fine. And then we go to site and see the thing, uh, but we don't realize the dimensions. But you're all excited, okay? As architects, we're all excited, and this is Richard Myers Jubilee Church, okay? And you see it and you say, "Wow! I mean, this is something which you can do." And of course, the context is different. You have our friend in Mumbai, and many of you all have been to this building, which is the Salvasau Church in Dadar. And what you see in this church, and I mean, my dad kind of stayed in Dadar, so he remembers the old church, which was a church built by the Portuguese, which has these Gothic, not Gothic, which has these Portuguese features, and it has this triangular kind of pediment, which actually is something like the imagery of a church. Okay, while Korea goes ahead and builds this, and many people, I mean, when you're doing a building which has which is going to be used by people, there's a lot of imagery of the architecture and whether the people will accept it. As architects, we say yes. He's built a wall around the church, which kind of keeps out the noise of the traffic. Fantastic idea, and he's created these courtyards to talk about cross ventilation for a hot, humid climate, and he's brought these skylights. Okay, uh, uh, and many of you see, I have, I think 10 of you have visited this place in the first year with me, and this was form finished concrete, and I mean, I have another lecture which actually talks about the concrete, etc., etc. But you see that this was form finished concrete in gray. Okay, and the people really didn't accept it as a church, and they said, kya banaya hai, this, that, and the other, and they go and paint it white, and there are lots of changes. So those color schemes you see is something more recent. And you have Ando on the other hand, who actually kind of brings this idea of light which comes in. So what I'm trying to say is that there are lots of influences which are there, okay, and of course Rosha by Corbusier, okay, fantastic building. I think all of you must visit all these projects to understand great architecture, where he does this concrete roof, etc. This wall, which is the left-hand side wall out here, which is the interpretation of a stained glass window, an inside space, it's a chapel, and the outside space. So if there's a bigger feast, the activities can come on the outside. And one of the important things he actually pulls out, he actually keeps a little opening there where light comes in, and he puts the image, a statue of Mary out there. If you visit this space, what Corbusier has done, he's not followed the imagery of a church, but he's captured the essence of this of a space. So the quality of light within the space, okay, is very similar to the quality of light in Notre Dame in Paris, okay. And these windows which he has done here, of course, this is highly dramatized because of a low shutter speed. You get a lot of light, but he's interpreted as stained glass windows, okay. So that's what so these are all the things which are going in your mind, okay. But now you have to get down to your own work. I mean, you have seen so much around this, that, and the other. Probably you all have visited auditoriums. You want to do something else like that, etc., etc. Something is important. Some concerns are there, etc. And you start designing. Please note, we don't even have the site right now, and we know that someone tells you, it's probably about 12 meters by about about 18 meters, etc., etc. We don't have the site, but we start thinking, what is this space all about? Okay, how do you kind of, since it's such a tiny plot, how do you kind of accommodate all these activities? And you do several iterations. Okay, and while you're doing the iterations, you can actually start seeing some structural members coming in. Okay, while you do these iterations, you start seeing some ideas of a stair coming in. Okay, while you do these iterations, you understand that there is something like a lift block coming in. Okay, so this happens continuously. Okay, this happens continuously, and you have to learn. uh, there's nothing which this comes first, that comes second, etc. And then you start saying, okay, maybe this can become the staircase. Since it's a small plot, how do you get maximum area? And that's when you actually put a basement in, and you say, yes, let's see, how do you get light which comes inside, so that you get basement, because basement is free of FSI, so you know your norms, etc., etc. And maybe the basement can work out for parking. So, I mean, there are lots of projects which builders do where they say basement is for parking, and later on they sell that area. And one of the rules in Mumbai is that you can actually take the basement to the edge of the plot, but the building is 1.5 meters from the edge, and all these kind of things you try. These are all sketches. Okay, these are all sketches, but there is some notion of what needs to happen. Okay, and then we talk about a community space down, a cultural space up, and then you actually build the you can see this idea of a green roof possibly there, etc. I mean, uh, thoughts. And this is in 2013. Okay, somewhere in August 2013. And along with that, we make a lot of models. Okay, uh, if you get into practice, and I hope you all do, making of models, a physical model has its own charm, because very often the client doesn't understand what you're proposing. You may give all the drawings in the world, but he doesn't understand a damn. Okay, so there are a series of models with different iterations. So in this case, we were saying maybe the community hall, the church, could be at that area. Okay, with a more permanent kind of material palette, while the upper level can have bamboos. Okay, so it actually talks about that. We also looked at the possibility of the semantics, that maybe this church needs to have this kind of pyramidical shape to actually talk about architecture of a church. But you can see the community hall, the church is out there, and that goes there. So if the community hall is here, that means the residential areas for this building is at the upper level. This community also had an ashram where they used to pick up people from the road of any religious background, etc., etc. So they look after these people, okay, and they stay there. So I mean, I mean, the people actually, the youth and the people actually look after these people. Very often, there are 2, 3 people who are constant, but they come and cook and whatever. So I mean, so that was one of the other aspects which had to be incorporated within the plan. Okay, and then we said, what if the building actually expresses itself like this? Okay, uh, you can see this arch kind of a formation with this whole opening which works out there. And once again, if the community hall is at the lower level, then the residential part enjoys this aspect of this curved roof. Okay, since they enjoy this aspect of the curved roof, the community really doesn't get this idea. And then this further expresses itself much more strongly. What if we do something like that? And once again, if the residential activity is there, can we move the community hall up? Does it make sense, etc., etc.? These are the thoughts which go in your mind. Or can we then start bringing the community, this kind of aspect at the lower level, so that you don't, the residential part just becomes simple slabs. Then we say, what if we express the community hall very differently while the residential acts like a block? Okay, these are thoughts. I mean, they are just sketches, but in model form to kind of understand that. And then where do you say, what if we club the two together? Okay, and if you're building in a city like Mumbai, you talk about the maximum FSI which you can actually use. Okay, so that's one of the things which you look at. But now, the first thing you do as a professional is you actually get a surveyor to actually survey the site. Okay, a surveyor comes on the site and he actually surveys the site. So it's about 18 meters by 16 meters kind of a thing. But one thing I want you to realize is that since this is a road, okay, the building compound wall for the site is within your property. Since this is a adjoining property, an adjoining property, and an adjoining property, the compound wall sits halfway in your site and halfway in someone else's site. Okay, and of course, you get this drawing from the surveyor. Okay, and once he sends it to you, you have it today. We have it on CAD, so there's no big deal about it. And then you start making what are the possible sections, and you can see this idea of the basement. One of the things I forgot to tell you out here is that if you talk about 15 meters and you talk about your setback lines, okay, you'll get about a building about, supposing you will say 1.5 of the building. At the ground floor it'll be more, but at the top level it's 1.5 less, 1.5 less, so that's about 3 meters less. So automatically you're talking about a building of width of 12 meters. Okay, and the dimension from here is about not more than 6 meters, etc. So how do you, one of the things which came to mind is, how do you view this building? Okay, do you get the distance to actually view this building? And what are the one of the strategies I thought about is, rather than put this as the main facade, why don't we turn because people come walking down this road, why don't we turn the facade over two sides so it becomes larger? Okay, so you get a larger surface. Now these are design moves. Okay, these are design moves, so you have to understand that all of that works, etc., etc. um, uh, uh, you get your north and whatever, everything worked out, yeah, and you work out your section, yeah. So that's the ground level, plinth level, first floor. This would technically be the second floor, but we called it the mezzanine, second floor, third floor, and terrace. Okay, so you're talking about a limited FSI of about 4 floors. Okay, that's the kind of space. And one of the things, then you have these discussions with the client. Now in this studio, we are your clients. Jimmy, Meenal, Kimaya, Neeraj, Dharmesh, and myself. I hope I've not missed anyone. We are your clients, and we'll say this works, this doesn't work, and client says, no, no, I don't like this step of this mezzanine. Okay, because this dimension is so small, you won't be able to view into the altar area. So he says, I don't like this step idea which you're doing, because I want to use this for other activities. So they have some religious education which happens. So maybe a classroom can happen there. This can become a cultural space. So we and stilt parking, and then the ashram and the priest residence, and then we make layouts. Okay, so it's a trick to actually get a ramp into a basement. It's really tricky. You have to have your turning radius, how the cars back out, blah blah blah, and we start making plans. Okay, now in this case, everything out here is north up. Okay, so I've turned this is the main road, these are the two gates. So I've just changed the orientation from this part onwards, The presentation will only have this as the north up. So yes, so please understand why am I telling you this? Because when you'll actually make your portfolios, you can't go on spinning the drawings around. Once you decide that this is north up, everyone will start reading your drawing in that light, and you'll design with that emphasis. So that's the main road. This is an adjoining plot, and then we try to work out the basement parking, and then you realize there's a lift block because you're talking about accessibility for the physically challenged. The staircase starts coming in, and the prayer hall, a mezzanine. So you actually view in this idea the altar is here, so the congregation is facing north up. Okay, I'm making a mention of that to kind of make you understand how things change. And some sketches of what the facade is, but you'll see that this becomes a public area and whatever happens there. Yeah. And then another sketch where we say a more concrete kind of hardcore building sits out there for the altar and the mezzanine, and then a kind of a bamboo facade which goes there. I mean, but now the licensing architect comes in, okay, and this licensing architect says, "Wow, guys, the thing is, there's a rule in the BMC which says that if it's a trust, you can actually get an FSI of 2, okay, and you just pay a little premium, and that's possible." So a building which was maybe 3.5, 4 floors actually has now become 6 floors. Okay, you can see how uh, regulation has transformed what the project is about. Okay, and you start then articulating the prayer hall. The sacristy is actually a space in a church which is where a priest wears his vestments, and then comes to celebrate the mass. The choir, the mezzanine, and then because of this extra space, we can actually put in a multi-purpose hall. Okay, we can call this as a multi-purpose hall for the ashram, where these guys in the inmates in the ashram make these little garlands or something. So they're doing some activity throughout the day, and then the priest room comes up. So there's a, like in design we talk about a hierarchy of spaces from public to private. This is something which actually works out, and then you get a terrace. And the BMC architect then comes and says, listen, boss, there's a regulation where your building cannot go more than 24 meters. And then you see this, that you work out 22 meters. So I mean, as you go through the process of putting your plan together, all these kind of things come together. Yeah. And you see that basically the floor to floor height is about 3 meters. Okay, now I can push it up because this is 22 meters, so I got 2 meters to play with. Similarly here, you can see that basically it's 3 meters and 3 meters, so you get 6 meters. So all these kind of things work out. Now there's no rule about 3 meters. In some other project you actually take more than 3 meters. Yeah. And then you start putting it, I mean, please understand that y'all are doing this individually, while in office we have people to actually do it. So while I do masti in college with all of you, there's someone actually working behind the scenes for all of this, and then we kind of review it. Okay, and this is now 14th, okay, 2014. So that means 2 years have passed. Okay, and we are still in the design, getting all these kind of things in place. Okay, and here this I mean, we had kind of worked out, like, if this is the altar, people can sit here, there's a mezzanine out there, the choir can be out here. Okay, now I used to sing in the choir, and I know the masti and we used to make, which can be distracting to the people. You're fighting over sheet, someone forgets the word, someone singing false, you make faces, all that nonsense happens. Someone singing off key, you want to shut them up, blah blah blah. So that can be distracting. So I was wondering if you could get 3 levels to view the altar. The choir above the altar will not be acceptable, as the choir can get distracting. How many can sit in this? So you have to understand that the functions of an auditorium which you are going to look at is also important. So you'll have to constantly think of the number of seats and the capacity which you have given you. Okay, it's not just making a space. You have to understand the sight lines, which I think Meenal is taking up in the next class, so that everyone can view it. Okay, Jordan is the architect, is giving us 1 week to finalize the drawings before finalization of the drawings from BMC. So you can understand that the schedule which Meenal has put out to you, you get this schedule in real life. Okay, we are simulating real life in kind of activities. Okay, we are, so all this nonsense of not getting internet and all this jazz is something which doesn't fly. And then we do our own experiments, okay, with how light can come in. Okay, now this goes back to Jubilee Church, Rosha, blah blah blah. Can you say that this is from Ando? Maybe yes, maybe no, blah blah blah. That's the altar which is pretty high, so someone can view from the upper level. All these things work out. And then we say, what if we make 3 levels? So then what happens? So this goes further down, this goes up, and maybe you get a choir space out there. And these kind of skylights start coming in. Masti. Okay. But then we now start coming down to the hardcore rules, and by then the structural engineer is appointed and he starts coming in. Okay, it's not that we don't know structures, but I mean, he does all the calculations of the reinforcement, the forces, blah blah blah, this, that, and the other. And we start, so once again, north up, this is the main road, these are the entry. And then we start saying, okay, now the BMC guy has told us that's what the footprint is going to be at the upper level. So you can see it's really tiny. Okay, we talk about an elevator, we talk about the staircase, and we talk about this as a cultural space which actually can extend right up to the compound wall. Okay, then on the upper floor the staircase comes here, the lift, the sacristy, which is part of the so if you understand, the sacristy is adjacent to this church hall. And then we have a cutout, and then on the upper floor you probably have a choir loft here, or you have extra people sitting up there, but you can actually view down. The next floor, the third and fourth floor plans become the multi-purpose hall and office. As And then in the upper level you actually start getting your ashram. Okay, so it is little complicated. They said we want 14 beds. Okay, and here you can see that we have only 3 and 3 6. Then I said, we can actually start using bunk beds because your site is so tiny. So there's an activity space on one floor. There are toilets which work out there. Okay, and on the next floor there is a dining space, bedroom, kitchen, blah blah blah, which you'll actually have to work out, and further investigations. Out here you can see how we are trying to actually hold on to that bamboo idea in a more concrete kind of a thing, which works out. uh, Now we're getting into computer simulations and physical models. So can this then become the hardcore part of the building, and then this become the spire or the steeple for the building? So actually it becomes a little bit of a landmark in that space, and play with light, etc. Various sections which are worked out. But here comes the structural engineer which comes in, and now we get into details and drawings and dimensions, etc., etc. So the idea of columns start coming in, finalization of the drawings. You can see not very much has changed, but then you have someone in your office and you have to mark this out. No, the drawings do not match plan and section. Okay, we are still in February 2016. Okay, so you can see how much time has flown by. So please understand that this profession does not happen like a building doesn't come up in a day. It will take probably initial work, etc. By the time you're appointed, it'll take maybe a year or so before they give you that appointment letter. However confident or however great an architect you have, every project is a new project, every client is new, and they treat you as though you don't know what you have learned. Okay, so yes, now may not be allowed because it's 24 meters. And then the structural engineer comes in, and वो तो वाट लगता है, he just has fun with you. Dear Ainsley, the situation of load transfer safely to the foundation and withstand earthquake hazard is precarious at this stage of planning. I have some suggestions, please ponder it. Still flow, the stage is in the right position, the columns are in a radial direction and would not affect the functioning. First flow altar may be shifted, second flow blah blah blah. He's made a mess out of my ground floor. Okay, a mess. Okay, there's no way in which we can have any kind of cultural activity here with all these columns protruding out. You can see how the lift has now, we have now shifted the lift to kind of make one lobby area staircase lift. You will understand when you actually get into practice, the this dotted line is actually the setback line. Okay, so we have made one column here and the stair cantilevers into this open space. So that's allowed by the BMC. So you climb up the stairs this way and you go up, blah blah blah. So it's a single column where the treads and risers are cantilevered on both sides. You need to know all of this to make this happen. Yeah, otherwise you will not maximize the site. And here he has fun, this is what happens. And then there's all, you can see you can't have a congregation. Imagine you telling me, sir, this is an auditorium, but because structurally I need a column, I have to have it here. Okay, but we entertain him. Okay, you cannot just say I give up and I fire you as a structural engineer, etc., etc. You will be fired by the client. Okay, so you have to understand, you should know your structures, and these lines in pencil is something which I have sketched out and said maybe we can do a waffle slab and remove this and change the columns, maybe we do something else, blah blah blah, whatever. And you can see how every flow, these columns are, yeah, are hassling the viewing capacity of the people, and then automatically the number of seats which come up are very less. Okay, so you can see at the ashram level now, which has become a full flow, the columns are actually coming within the toilets. How can you enter a toilet with a column there? Okay, how can you have a bed with two columns on either side? Okay, how can you have columns like that, and suddenly and automatically this becomes a problem. Please understand that all rooms need to have light and ventilation. Okay, um, and we go on. And then I said, yeah, as we are going along, can this fire thing actually become like that, and maybe this can become your bamboo kind of a thing, which becomes quite dramatic. And slowly we work with this and we start eliminating columns. There's a lot of give and take. And then we say, he says, yeah, maybe if you put columns in the central aisle, it may be okay, so more people can see. But that also is not acceptable. But it's an iterative process. So you'll have to make drawings and drawings and drawings and drawings to improve and make it better. Yeah, and we also work out the sections. And if you look at this and you say three, and he says, because it's becoming like a long span, the beam depth is so much. Okay, and 900 beam depth. So technically from 3 meters you'd remove 900, then automatically the headroom you're getting is very less, which is ridiculous. 7 feet, not acceptable. So what do we do with this? Okay, so and then I say, okay, maybe those columns can become something like what Frank Lloyd Wright has done, these mushroom columns. So we just have few of them, etc. Can the depth be much less at the upper floors? So these are some things which we are talking about. This 24 is, we know that this is the upper limit. And another possibility. Wow, these mushroom columns, what are the possibilities? Is this worse than what we are doing? And then we say, supposing we do the mushroom columns this way. Now you see that the altar which was facing up has now turned this way. Okay, this is a major milestone. This is all part of design development, where the structure starts coming in, the staircase starts coming in. Staircase is a very difficult element because you need to get your headroom. You start here, you come to a part of it, then you have to get there to the mid landing. That means when you enter from the ground floor, you must get enough headroom underneath. Okay, So I'll show you what that section is all about. Yeah. So the altar has changed position, and that's what you get as what are the possibilities. And we say, yeah, maybe that works, you know. You get these things and you get this double height space, so you get this kind of thing. This is all part of design development. More seats here. But the eureka moment happens on a Sunday morning where you're concerned that if you have columns like this, okay, you and your altar here, it looks so weird. Okay. So I sat on a Sunday morning, it just struck me, and I said, what the hell? Why don't we actually make these columns in an A frame? Okay. In an A frame, and subsequently we can actually do floating columns, blah blah blah, and work out whatever is happening. Okay. And I sent it to the structural engineer that morning itself. Believe me, I remember that date very clearly. uh, you can see that I'm not yet got into all the depth of the beams, etc., etc. It's just a simple diagrammatic idea of what that works out. And then he says, yeah, it can work. And then we understand that rather than taking this A frame right from the bottom, we can limit it from here. Okay, we can limit it from here. We can, rather than taking it from here, we can start it from there. But we will need a tie because this has a tendency to move outwards. So you need to tie it up to hold it together. Okay, and structurally, the engineer says yes, this works because this becomes the anchor for the building. This becomes the frame on the other side, and these slabs are just connectors between the two. Wow, all my problems were solved. And then we start putting in the details, and then we says, okay, then he gets into the depth. Then we tell him, no, this doesn't happen, 1.2 meters is too wide, can we reduce it so that when people are there you can't see. Then the idea of this tie beam which works out there, etc., etc., blah blah blah, and we are back to model making. And to reduce the depth of the beam, we talked about a waffle slab. So we start making models. These are paper models. You can see all the confusion. Someone's hand, I don't remember who's this staff, but a hand is there in the background. The drawings are there, whatever, whatever. Yeah. The inside space of the model. Yeah. And then we make, as we go along, this is of course much later, we start understanding what this A-frame is about. And out here we actually drew a 1:1 to understand the inclination of the A-frame and the width of this and the size of this. And that's what the A-frame came. So you understood that initially it was an arch, then we have flattened it, so that becomes a tie. This A-frame can't just stand independently, so rather than have columns there, we have actually made a circular kind of beam here, and that's what you get. Understanding scale, understanding various kind of things, and this idea of what the duo is about. Yeah. So what I'm trying to say is that you have to understand that all of this happens simultaneously, but you'll address one issue at a time, and then you get into the detail, and then the client says, yeah, I love stained glass, why can't you do a stained glass? And so we actually made a cutout. This is an east facing cross. There's actually a cutout with glass there, and we actually put a cross out there. Is this Ando? Is this borrowed from Ando? Is this borrowed from Corbusier's Rocha? I don't know, but yes, definitely I would agree it is. Yeah. So there's something which touches you, which makes a difference, and then you start putting it in. And that's the model of the building. Okay. Where this is the main road, and as I told you, we turn the facade both sides. This idea of the bamboo still remains. Okay, still remains. We definitely want to keep it. There's this idea of some stained glass windows here, which I'll show you what happens. And then this is what you have to achieve in this semester. tender drawings in BOQ. I think Neeraj and Jimmy will then take this on, okay, and you can see the precision in which this works out. The line weights in AutoCAD. Please understand, guys, this is a very serious year. There's no messing around. This is the kind of quality of drawings which you have to kind of give us. The size of the lift actually gets into its size. You would refer to a catalog. The staircase which works out that singular column where the cantilever, there's a meter room, your public toilet, etc., etc., that should be worked out. The meter room which actually carries the electrical ducts, I'll show you how it works out, but that's how it has to be done. Yeah. And then the idea of those columns, and you'll see that these columns are not because we needed two main columns. I forgot to tell you something. These two columns go, sorry, these two columns go straight from the bottom to the ground. Okay, these two columns go straight from the bottom to the ground as clear columns. The rest of the columns dance in between. So these two go straight up. Yeah. And that's why they're thicker. While these two columns stop at the first floor level. Okay. So I mean that's something which but proportionately I wanted all of them to seem the same. So I mean we are concerned about this and we actually got that to work out. Okay, there's a cantilever of 2 meters here into the open space which is allowed. That's your entry, etc., etc. And then we get into the, now I'll go a little faster, where we actually start the work on site. I want you to get into this. We would technically end at the working drawing, at the tender drawing, where we do a BOQ calculation, etc., etc. But I will just quickly run through these images of the work. Excavation happens, you do your footing, the ceiling for that, and while we are doing that, suddenly the walls start collapsing in. I think Jimmy and all of us have experienced this in all our projects. Okay, the only issue here is while we were excavating, we found water. We were very happy, but it was actually sewage water from the building side. Okay, and we did not use piling, so there's ways to determine that. And then because of that happening, you have to consolidate the edges. Okay, and they work throughout the night. Okay, to ensure that more doesn't fall. You can see that you have reached the compound wall, and all this happens while I'm entertaining you in college. Okay, and that's the entry to the side. There are two trees which we have to hold on to, and now you can see that we have kind of consolidated the edges, but work happens day and night. You have the whole reinforcement put for the footing. Okay, because the columns in this area are very close to each other, the lift, etc., etc., the staircase column which is there, so that you consolidate it with bags, then you put a mesh and you gunite it. Yeah, so this is how we kind of consolidated it. And then you, once you do the, this is the lift shaft, this is the rear part of it, and this is the front part, and then you have your columns which your beams which actually tie the whole thing up. That's the layout of the beams. Okay, now this is at the foundation level. Okay, this is at the foundation level, so you can actually see the beams there, and then you see that coming through, and these are the 4 columns in the front. Okay, this is the foundation. This is about 4.6 meters below ground level, because that's where we got worthwhile earth to take the capacity which you'll have done in first year. And that's the lift shaft, where the waterproofing is done on both sides. This is called box type waterproofing. I mean, someone will explain it to you what it is. And now we are filling up the whole thing. So we are coming back to ground level. Ground level is here. We are filling it back. And now we are putting your plinth beams. The plinth beam layout is also in sync with what your ground floor layout is. Sometimes you actually subdivide the space so that you can consolidate. I mean, there's no wall in this space, but you can actually fill in this, otherwise it starts settling over a period of time. So all that happens, that's that column. Okay, can you see all the mistakes which happen there? And that's what you have. Yeah, but you actually detail it out, so you can see that big beam which is there, and this is the beginning of the inclined column. Okay, the reinforcement actually goes into that. Yeah, and that's what you get. So that's the beam, which is the tie beam, which holds these two inclined columns, which is there. So it becomes a stable structure. That becomes the cantilever. And you can see that the edge of the building I wanted in ending at a certain level. So you can see this cantilever is further, but the beams are worked out. Now, as architects, we have to think about all of this. A structure and you say beam to dalo, and you might say this edge should be bigger, but you'll see this like a tooth. But here we have worked it out so that the edge is all at one level. Understand this. Yeah, that's the inside when you're looking at it. And I'll go, and that's a kind of drop beams and whatever, whatever. This is the first level. And uh, this is in 2017. And as architects, we have to also sketch out, okay, proportionately, because we have to give details like this. So you have to get your act together. You have to understand 3D, etc., etc., whatever. So floating column, blah blah blah. What is happening here? Part of column not on any beam. You have to tell the structural engineer, whatever. Yeah. And then this cantilever kind of staircase. He makes a mold in GI, and this part of the building, once again, because it's in the open space, uh, it cantilevers from this wall. So you can see that this becomes the anchor for the building, this becomes the frame, and everything is just attached to each other. Yeah, that's the staircase, cantilevered on both sides. You can see similar cantilever. All this has to be detailed out. That's what the building is. And within this staircase, I said we need to have, within this column, I said we need to have little cutouts for lights. So public lighting, like this is an ashram. So at night, if people have to go up and down, we don't need to put very expensive lights. Small lights happen, and we have worked it out. But part of the construction is to understand what's cover for reinforcement, what is acute testing equipment. All this happens, and these are the drawings which come in. These are doors and whatever, which works out. Yeah, and you can see the two inclined columns happening here, one on the left and one on the right. Okay, and the curved beam. So what we made in paper is actually becoming hardcore architecture. Okay, and if you look at this column, this side of the column is thinner while that is wider. I don't know whether you can call it a beam or a column, but yeah, and that's the altar space. And we have radial beams for the waffle slab. So we have a great contractor who actually made this in laminate. So his people knew, and that curved beam is a huge beam of 1.2 meters, so that it becomes a parapet also for the upper level. So you see that coming up. You can see the curved reinforcement here. Yeah, and of course the reinforcement starts coming in. That's the curved beam. Yeah, that's when it's cast, and you have this which happens. And in that big A-frame, I actually insisted that we put a quotation, something from the Bible there, which we made in. Today all this is laser cut and whatever, so it's easier. But that's what the conceptually what the building is about. The solid kind of anchor which is there with the lift and the lift machine room, the A-frame, and the rest of the things. And that's what the work is out. That's how it is. And this is the finished kind of a thing. There are mistakes. I'll show you. There's a mistake here, but we'll see. Okay. Can you see this B? The upper part of the B should be smaller and the lower part should be bigger. But these guys put it ulta. We got it corrected. Nothing. I mean, mistakes happen. It's okay. And this is from the bottom when you're looking at the top. A sunburst. And when we look at this, this is, you get excited. So I go back from college and I go to site, and you actually see this. You're so excited about it. Yeah. And that's the thrill of being an architect. I'm very sorry, the sound of this video is not playing because some reason. Yeah. But you understand space, you understand what you're doing and how you worked hard for it. Yeah. And that's what you get. This green material is a new product which is in the market. It's called Bondit. So earlier we had to hack the columns. So you make good columns and then you hack it and the beams and whatever. But now this allows plaster to adhere to it. So new kind of materials. And the client wanted the first two floors in stone. So I'll show you what we did. That's the upper floor. And then we'd actually do the stone cladding. Okay, so all the work which I taught you in first year film, the when you actually put stone, you should actually not have continuous joints, the level, etc. That comes back here. Yeah, and that's the cutout for the cross. You can see the reinforcement going through. That's the stone. Can you see the staggering of joints? Line level is very important. That's the cross which comes up. And that's, so the first two floors here are of stone. Yeah, and then the rest is in, that's what we do. You have to convince the client, by the way. Yeah, so the windows are something, the first two floors are in wood while the upper floors are in UPVC, and that's what you get when it gets finished. And then the making of the crucifix, this is the altar space which you can see on the bottom right, and the wooden windows. So this is the wooden windows are out here. Yeah, W5 and whatever, and the upper floors. I mean, I'll go through that, but you get this. This really works. So you get open space everywhere. That's the layout now of the ashram, and that's the priest residence. And even when you do that, you ensure that the terraces, etc., have the water outlets, which you have to work out. The lift machine room has to have the staircase which goes up. The slope should be there. And then the client was, hesitating. Are see, you're doing this, but this color is looking too dramatic. Okay, then you have to do these possibilities and show how it looks, and then he gets convinced and you actually make this. Yeah, and this great bamboo kind of a thing they eliminated, and then we use these UPVC kind of verticals to cover the windows. Yeah, that's the inside space. There's a whole kind of big talk which I can give you on stained glass, but I'll quickly take you through it. So you can see the light which comes in from there, east light, that's the stained glass. Okay. My experience of the stained glass came from Gloria Church. Okay, so this is a model which we made in the office to scale to understand each of the parts of the stained glass. These are the drawings. So you didn't realize that it actually is in a concave kind of a feeling, and the windows actually are worked out. So that's what you get. Yeah, and those are the windows. And in each of these windows, we fired a pattern with biblical imagery. And that's the north side of the building. So you can see the stained glass. That's what we have fired into the glass itself. Yeah. And that's the upper level. The furniture is also designed by us. And these are the we are actually showing the client's back is in red. My staff is holding up that thing, and that's the stained glass person. So we actually make 1:1 drawing, show them the color, etc. What are the possibilities, because these are painted glass pieces. And that's what the building looks like. So as I told you, the front is very narrow. Okay, that's why, and that's the kind of light which comes in. Ando, I don't know. Corbusier, I don't know. But it's an experience to actually get the light hitting you. That's the ground floor. You can see the beams. Those are the little balconies. This is the multi-purpose hall. That's the south side. I didn't tell you about this, but the south side we kind of blocked it out because of the rain and the heat, and that's what your building is. Yeah, yeah. That's it. Meenal, 1 hour I took as, yeah, 3 minutes above the 1 hour. Yeah. Any questions? Any questions?
Sorry, my hand raise isn't working. Um, but
Yeah,
so
go ahead.
when like I think earlier you told us a lot about last minute changes on site in the first year. So, for example, now that the bamboo was changed out, how deep in the design were you when the bamboo was changed out? Were there any like issues that change caused, or
See, the thing is, when you actually talk to a client, uh, um, uh, you get a sense of what's happening. Initially, when you meet a client, you have no clue about what's in their mind. But as you go along, you realize this. I didn't show you one proposal where I imagined this whole thing as a little because there was an ashram. I thought the whole facade can be planted with vegetables. So the ashram guys, inmates would actually look after the vegetables, and the facade above the community hall would become like that. And that's when the client said, no, no, I mean, it's a great idea, blah, blah, blah. But the question is that if the person does not maintain it, it will just become ugly. So you get an inkling about it. Okay. There was when we actually do an estimation of the project, like I've used UPVC as these fins, but initially I thought of aluminum, but aluminum was far too expensive. Okay, so you get an inkling. So I mean, at some point of time, you have to win some battle and lose some battle. Okay, and you have to determine which battle you need to win and which battle you need to give up on. So as you'll get into the profession and you'll start working, it's like, for example, you need to prioritize, like even when you are doing these projects. I mean, there are two studios which you are doing simultaneously. You need to actually understand how much you need to do where. And you most of y'all will actually work harder on this studio because it is a known. Okay, conceptually, I mean, you might take a stand and we agree to it and you'll go ahead. But in reality, you have to be agile enough to kind of accommodate all these things, resilient enough to listen to criticism from everyone. Okay, so there have been times where I fought with the client also, and he said, I'm leaving, I'm never going to come again. I said, okay, fine, whatever, but you have to have the ability to say no. I mean, I didn't really mean it, it's in the heat of the moment, blah blah blah, this, that, and the other. So yes, I mean, the bamboo thing. Maybe when the whole building came up, then you actually see the project costs, and the bills start coming in, and you realize that he wants to like, when we looked at marble which was around $400, but now the contractor saying that you are getting this. He goes to the not the quarry, to the go down, and the client and I go to the godown and he says, no, no, I don't like this marble. I like this marble which is 700 bucks. So that means 300 bucks per square foot extra. So where do we get that money from? Automatically the client will say compromise here, but don't compromise. I'm not bothered about your bamboo nonsense. I want you to do this. So all these things happen. So that's what I'm saying. You need to win some battle and lose some battle, and that's how it is. And you'll figure it out. So I mean, as faculty, we are going to tell you like if Meena, Lokimaya, or Jimmy or Neeraj or this one says this is what you need to do, you better understand that they have some knowledge of and experience to tell you what should be done, and you cannot be stubborn and grumble. Maybe you'll talk to your buddy or talk to someone, discuss with them, maybe your group mate, etc. But yeah, that's how you this. So it's we're in this studio we are simulating real life activities, yeah, with material technology services, and eventually first semester we are only talking about a bill of quantities and tender, but in the next semester we are talking about a working drawing, which is a language in which you explain to people, like for example the model, all these models which I made were on site, so they understood. अच्छा ये ऐसा building बना रहा है. You can imagine how in spite of making so many drawings, okay, how much you need to do to kind of convey to your site guys. Yeah. Any other questions? Any faculty want to add on or whatever? Jimmy? Jimmy, anyone? Meenal, Kimaya? Can you all hear me?
Yeah, we can hear you. Can you hear
Yeah,
me?
yeah. Yes, yes, we can.
No, we can hear you, NC.
So I'm glad Ainsley, hello. I'm glad
Yeah,
you took,
say.
in some sense, your project is a gathering space and it shows all the procedure you went
I'm glad, Ainsley. I'm glad you took up, in some sense, your project is a gathering
innovation in its planning,
space and
innovation.
We have lost you, Jimmy.
it shows all the procedure in through to be in a position to large span structure, innovation planning, innovation in its planning, and the entire process of planning, structural intervention, innovation, contractor participation, client participation. I think these are all important points, and thankfully you've covered
But
them. I like to then an intense studio for quite long, which in reality does go. I did a similar project, and sadly the students have to be in a position to take quick decisions through interactions. They in a month they are supposed to wind up the design and get to the. But that also shows that there are offices that demand projects to be done within weeks and months and cannot afford to go on. Some private trust projects usually pull on for times, but that's not the truth with some private projects that happen in the city. So in that sense, you'll be expected to work in a time period that is going to be short. But I'm glad you made the presentation today, and I hope the class has got to learn from it a lot.
But students here must be excited about this and passionate. Otherwise, and yeah, and Meenal, are you saying something?
No.
Okay.
I I think I just wanted to say that it was a nice presentation, and I like the structural part of it that you discussed, and I hope that the students got it. That it's a iterative process which keeps on changing and it's okay to change if it works for the project. So yeah,
Okay.
I hope they
Amrita,
learned something.
Ambika has a question, which of course definitely will be taking up in your DCR calculation later on. But just because she's asked the question, I will tell you a little bit about this fungible FSI. Okay, fungible FSI. Okay. Um, eh, uh, Prior to so maybe 12 years ago, the the builders in Mumbai used to actually build a building, okay, and they would actually make these flower beds which was 2 feet around the building, okay, and say that they are flower beds, okay. So technically in section they would be at the lower level of a slab, okay, um, and that was free of FSI. That was free of FSI, so there was no kind of charges on it. So the builder said, okay, fine, because when he actually constructs a slab, the cost of construction of a slab was about 2,000 rupees a square foot or whatever, maybe with finishing 2,500, 2,800 max. But he would sell in Juhu area, he would sell it for 25,000. So it was a whooping profit for the builder. For me, as a resident buying the thing, I didn't mind paying the 25,000 per square foot, because when I sell later on, I get a bedroom which is, instead of 10 feet by 10 feet as a habitable space, I get it 12 feet by 12 feet. Okay, because imagining the two sides, I get this 2 feet 6 inches extra. Okay. Um, I think I told you in first year that when I was teaching construction, that the veranda, okay, the balcony, these were all the areas which were supposed to get wet during the monsoon. They're supposed to get wet. That's the idea of a veranda. It is a transition space between the elements of climate and your space which has to remain dry. But the builder definitely wanted to sell that. So after they got the approved and the occupation, they would break that wall and extend the bedroom by 2 feet 6 inches on both sides. Okay. Um, Subodh Kumar, who was the municipal commissioner, realized this and said that let's not fool ourselves. Okay, if the builder is making money, if the residents are making money, why shouldn't the BMC make money? So what they came out with a new regulation saying that all these areas, okay, the flower bed area, etc., uh, is included. So they worked out something as fungible FSI, which is 15% of the total built up area. Okay, and you pay a premium for it. You pay a premium to the BMCA for it, and automatically you can build that much, and it's allowable. Okay, so all these flower beds were supposed to be considered in that fungible FSI. But if you look very closely at the architecture belonging to a particular DCR regulation, like if you look at the buildings in the 40s and the 50s, they were like boxes with balconies which would come out, okay, and they would be considered as balconies free of FSI. Later on, when the DCR changed, they talked about this planter nonsense which should come out, which would make the architecture of the building, okay. But post that, now with Subodh Kumar talking about fungible FSI, they actually talk about this extra FSI, and you can actually see now the buildings are back to the boxes again, because the anything which is built beyond that is considered as fungible FSI. So you might as well put it within the flat itself. So there's no decoration or icing on the cake, as I would put it. Okay, so uh, only the basement is free of FSI. Okay, and everything else everything else, okay, and cutouts, etc. Obviously, for lift shaft free of FSI, they allow for a little bit. The rest of the areas, like they also allow for the cutout of the lift shaft in front of the lift shaft as free of FSI. Rest of all the lobby areas, everything, etc., is considered in fungible FSI. Yeah. Uh, as practicing architects in the city, etc., we usually, I mean, if you consider yourself as a design architect, you might not, you should know about this so that you can make plans to your advantage. But in reality, I don't think many of y'all will actually, or some of y'all may actually get into that because you'll have parents who are builders or developers, etc. So there are some of our students who are doing very well in that kind of a thing. In fact, I use some of them right now. So for my projects. So yes, they actually talk about this idea of fungible FSI. Nothing for you to be concerned about for this studio, but it's good to ask and update yourself with regards to this. Yeah. So it's a premium you pay for all these things, like lobby areas, etc. But technically now, because it's you're paying a premium, you consider it within the room itself. Yeah. Clear? Any other questions? You'll get into the nitty-gritties of it, and you'll get into the nitty-gritties of any projects once you get into practice. And believe me, it's another thrill and joy to practice architecture. uh, because you know every part of the building, you know every aspect, any column, every problem which was there, etc. So it's like your baby. Yeah, you've built it and you know whatever. Even the faults are there. So in the rains, if something leaks, immediately you get a call. So we cringe, but yeah, and you've got nothing to do with it because the contractor did bad work. But your detailing is important. Your detailing is important. Yeah. Any other questions? Yeah, but I think all of us will answer all your needs and wants and desires. But yeah, but we are like Khadu's. Imagine we are like Khadu's clients who actually talk about these things. Yeah. So please don't. I mean, be there for every class and whatever. Clear? Shall we move to our teams? Maybe give them a 10-minute, 5-minute break, whatever. Yeah. Yeah.
Yeah.
Yeah. ठीक है. Okay. Thanks a lot. Take
Yeah.
care.
Thanks,
Bye.
Ainsley.
Bye. Take care.
Thank you. Thank you.
Thank you.
Bye.
Thank you so much.
Bye. Bye. Take care. Someone's stopping the recording. Yeah.